Hello all, welcome to the subject of the microcontroller. I am Professor Meenakshi Pancha from Electronics and Telecommunication Department of Parvati Bai, Yanma, Moti College of Engineering, Aguli, Pune. So today in this lecture we are going to study how to interface ADC 0809 with the 8051 microcontroller. The figure shows here the figure shows interfacing of 8 channel with a 8-bit analog to digital to the 8051 microcontroller. Here the figure shows here 8-bit which is connected to the 8051 microcontroller and which is having 8 input channels and which is having a 8 input channel IN0 to IN7. And in order to select this input channel, it is essential to send 3 address on ABC. 3 address on ABC. So select which input channel. In order to select which one input channel at the time, so we have to send the address of this ABC on these input pins. These are the input pins. So the address of the desired channel is sent to this address input from this port. So we have connected to this pin to the port, second port of port 20 and port 2.1 and 2.2. So address is sent by the microcontroller to this analog to digital converter to these terminals or these pins to select appropriate which input terminal. And after 50 nanosecond, the address must be latched and it can be obtained by sending ALE signal. So after 50 nanoseconds, the address should be latched. This is the address latch enable pin. So sending the ALE signal. After sending this ALE signal, the address will be latched. And after 2.5 microsecond, the start of conversion must be made high. The start of conversion signal. Where is the start of conversion signal? Here, this is start of conversion. After connecting the input terminal by reading the signal on these pins, then after connecting, the address latch will be enabled to access the address and connect the input. And after waiting some time, the SOE operation, start of conversion operation will be takes place, and this high signal should be obtained on this pin. After that, the signal must be activated. Signal when activated, then the clock pulse is applied. When clock pulse is applied, after activating this pin, the clock pulse should be applied to activate this pin, and then after what will happen, the conversion process will be start. So to indicate the end of conversion, after the end of the conversion, this signal should be activated. After the end of the conversion, this end of the conversion signal should be activated. This will given to this an ADC to the microcontroller. It will convert the analog signal into the digital form. Then after conversion takes place, then the high signal will be provided to this pin 2, which will indicate that the conversion process is over here. Then 8051 pin P 2.6 and 2.7 are connected to SOC and EOC pins of this ADC. After the conversion is over, 8-bit data is present on D0 to D7. After conversion process is over, the digital data, which is present at the D0 to D7. So D0 to D7, the data is present here. To accept the data through the port 1. So the clock source of this analog to digital converter is from the crystal oscillator. So how the clock will be providing to this analog to digital converter with the crystal oscillator. From this crystal oscillator. But this frequency is very high for this analog to digital converter. Hence, 4D flip-flops are used for dividing the frequency here. Whatever the frequency providing from 8051, which is very high. So, to make or reduce the frequency, here we are using 4 delay flip-flops. D flip-flops is used to synchronize the frequency of the whatever providing the from the 8051, and the after synchronizing the frequency that will apply to the analog to digital converter. So this is the interface in connection, how to interface the AD analog to digital converter with the 8051. So this figure shows the timing diagram of this analog to digital converter. So this is the clock pulse. The clock pulse is whenever high. So here there is start of conversion operation will be takes place after accessing the latch. See here, whenever the latch is enabled, then this process will be takes place. After start operation will be takes place. Then analog to conversion operation will be takes place. Then after that, after conversion, this end of conversion, the signal will become low here. So it will indicate that the conversion process will be end here. And after the end of conversion, here the data will be accessed. Here data will be accessed when output enable pin is high. When the output enable pin is high, then only the data will be present at the output terminal here. This is the shown in the figure. So this is the timing diagram of 8051. Now see steps to program analog to digital converter. So what are the steps we have to consider? The first step is, what we have to do? We have to select ABC input and required analog channel based on the ABC based on the ABC input. Select the channel. So according the address line ABC, so based on this we have to select one of the input signals. There are total 8 input channels are there. So according to ABC, we have to select first the input channel which we want to connect and enable ALE. After that, enable ALE. So this is the second step. For latching the address low to high pulse is given to this ALE pin. Then after that, we have to enable SOE, start of conversion process pin. So we have to pin by low to high pulse should be given for the conversion process. Then after that, what we have to do? Observe EOE pin. Observe EOC, end of conversion pin, to check whether conversion is completed or not. Check whether the conversion process is completed or not. Then fifth one is for reading the data after completion. After completing the process, conversion process, we have to read the data from this analog to digital chip. And how we can read? By activating the output enable pin. That is OE, output enable pin. We have to make activate. And how we can activate? By applying low to high pulse on this pin. Apply low to high pulse to this activate. So after activating this pin, the output is available at the output is available now. The output pins D0 to D7. So this is the simple steps we have to consider before going to write a programming for interfacing this analog to digital converter with any microprocessor or microcontroller. Now let's see one simple program. We have to write assembly language program to perform analog to digital conversion. So write the assembly language program to perform the analog to digital conversion. There is no any condition given. We have to assume which input terminal should be we are considering and start writing the program. So first bit is we have to select ABC. So how we are going to select ABC? To select the address etc. So how we can going to select? We want to select the IN7. So how we can select IN7? 111. A, B, C, all the bit is high and IN7 is going to be select. So how we can select? First, we can set the P2.0. This is nothing but the port 2.0 is going to be set, and set P2.1, set P2.2. So all these are address pin, which address pin A, B, C will become high. Means IN7 is going to be select. Then after that we have to provide a low to high signal to this ALE. So ALE bit. So what is the ALE bit is there? Where it is connected ALE? Here, this P2.4. So after enabling the address latch, then the output enable should be, we want to keep set the OE bit that is connected to port 1.5. Here 2.5 this one. Then start of conversion. We have to write start of conversion, setting a bit to port P1.6. This is also 2.6. So setting this pin P2.6, what will happen? Start of conversion will be, this pin will become low to high signal appear on this pin, then the conversion process will be begin. Then we have to wait for some time to until this EOC bit should be high. So call delay until this EOC bit become high. 2.7. Then data output is available at this port 1. We have seen the how to write the simple program. Now let's see the second program, how to write. So we have to write a program to interface this 8-bit analog to digital converter to the 8051, and we have to connect the channels CH0, CH3 and CH0, CH3, CH0, CH3 and CH7. We have to connect these channels and store the result in an external memory. What should we do? Store the result in an external memory. After conversion, we have to store the result in an external memory, and starting where the memory location is starting from this 000H, and repeat the same procedure for every repeat same for every 1 second. So this is the program. We have to write assembly language program to convert analog signal which is appear on the channel CH0, CH3 and CH7 and store the whatever the result into the external memory where the location is starting from 000H, and we have to perform the same operation from after every 1 second. So for that we have 8 input channels in our analog to digital converter. Hence, in order to select the input channel, it is essential to send 3-bit address on CBA inputs. And after that, the address of the desired channel is sent to the address input through the port P20, P21 and P22. Then after some delay, the address must be latched and it can be obtained by the sending ALE signal. Then after latching the address, then we have to wait for 2.5 microsecond to enable this start of conversion pin, and after that we have to wait for conversion process, and we can and these two pins, and we can wait until the high signal will appear on the our signal will be this in that conversion process signal will be provided at this end of the conversion pin, and those pins are interfaced to the microcontroller to the port 2, P2.6 and P2.7, and after conversion is over, the 8-digit data is present at the output line, and that is D0 to D7 lines, and after we have to accept the data through the port 1. So after we are going to accepting the data by the port 1. So we have to write the program like that. So let's start. First we are clearing CLR, the bit P2.6. P2.6 is nothing but we are clearing SOC. Clearing mask this start of conversion pin first low because we have to first address the latch. Then we are going to clearing P2.4, and this is about make ALE low. Then we are moving port 0, comma hash FFH